Right. I think we're live. So hello, everyone. Welcome back to another Reactor Meetup. My name is Rav. I'm the program manager here at Reactor London. And I suppose you know Liam, who usually does the intro, but unfortunately he's not here with us today, but he's here in spirit. So, and he's probably watching the live as well, and he says hi to everyone. So welcome to another meetup at Reactor. So before we get into the session, please take a moment to read our code of conduct. We're all here to learn, so please be respectful, please be kind, ask a lot of good questions. The chat is open for our online audience, and please do raise your hand if you have any questions. Some house rules for you. Wi-Fi password is here and is also actually displayed on a couple of stands around. Fire exits are through this door. Please follow the green man. And the toilets are also through reception. So if you go out of this room, the toilets are literally opposite, and fire exit is also through there. So we have an amazing agenda today. We have Sandra and Johan. Sandra's flown all the way from Germany. I think Johan from France, I suppose. And we have the opportunity here for a bigger conference, but we have the opportunity to have them with us here today, running this amazing session. Then we have a break where we'll serve some amazing food. After that, we have another session by Marlene, who is new to Microsoft. Actually, she's sitting at the back over there. She's going to be talking all about deploying a Python web app with Azure. And then we have a member of the community, Chandan, who is here, who volunteered to actually run a session. His will be the last session, and he is going to be talking all about Azure functions for event-driven solutions. But with that, I'm now going to hand over to our lovely speakers, and they will take it from there. So I hand it over to you. There you go.
We just the slides. Okay. That works. Okay, thank you so much for having us. My name is Sandra Ahlgrimm. That's Johan. Yeah, thank you. You can find and you can also connect via LinkedIn, or you use text for that one. I'm sorry, I forgot my glasses at home, but I think you can still recognize me. So, okay. Let's talk about what we're going to do today. So we created a workshop for ChatGPT, like we can build our own robot, not a robot, AI assistant here. And we did the workshop already at DevOps France like a month ago. We're gonna redo it at DevOps UK day after tomorrow. No, tomorrow. Tomorrow it is. And we're gonna show you what we did in the workshop, and also go through the slides. We're gonna share like the information needed to do like that one yourself. So like we come here with a small LLM crash course. So who's already an expert in large language models? So sorry, but that's great to have you here. So if I'm talking things not correctly, you can just raise your hand and correct me. That would be wonderful. So we will discuss a little bit model types, tokens, limits, embeddings, and prompt engineering. So like model types, yeah, you have like, first of all, the pure text completion models, which are like the easiest ones. Like they are specialized in text completion, like here. There you see the result. Or you can also use like a system prompt and also the user prompt. So that's something important to know, like to differentiate. So like the system prompt is what I gave my AI system to give like the round pillars. So like here you are a professional translator, and then if the user comes and do like, how do I translate hello in French, it would reply with bonjour. And also, like I can also do that differently. Like I have a 5-year-old at home, so he's always very keen asking questions. Like every evening, he should go to bed and sleep. But instead, he's asking questions like, hey, mommy, what's an asteroid? And I'm like, it's 9 p.m., you should sleep. And he's like, yeah, we have this encyclopedia, like Lexica, where you can search for it, and I search there, and it gives me like a nice long paragraph, even with like formulas, like how to calculate it, and even like more other words. He would ask me what to do, but I can use AI. I would just say in the system prompt, please reply like to a 5-year-old that he understands, like easy words, and then I fall asleep, and then it gives me like in like nice way, like the asteroids are like stones going on the you know it. So it's like super great, and also to know the differences here, especially if you like creating your own chatbot. I always put in the system prompt that if my AI system doesn't know the answer, it should not invent it. So it should stay honest. I think you all tried the ChatGPT, which came first, and I was asking like questions first, and then I also asked like who's Julian Dubois? It knows the answer. Then I asked like who's Sandra Ahlgrimm? And man, that was impressive, right? So that was a really quick resume. Anyhow, tokens. So like large language models, there we don't use words, but we use tokens. It could be words, like here with the first one with codex, it's almost words. So you can hear like we highlighted each token with the name, with the color. So you have it also like the special characters are here, and also like here's the tokenizing with GPT-3. And it's like very important to know. So you have like different numbers of tokens for each characters, and that's like if you have like your special PDF files or something you want to put into context for a large language model to be trained on, you need to know like the limitations of each language model. Yeah, so we have like the context windows here. So like for we have common limits around 2,000 to 4,000 key tokens, like, but also GPT-4 is able to use like more token, like more of those. It comes with like better systems because they are still all running on bare metal. And that's, by the way, the great work the AI and machine learning experts did for us. So that's all done in Python. I'm not a Python developer. I'm a Java person, and he's mostly JavaScript, TypeScript. I can do anything else. And yeah, so we need to know that we have the context window limits. So if we have like very long abstracts we want to use in our university, then we need to put that into account, that we need to use like the models working for us.
Yeah, also it's good to know that you probably seen that like new models claim to have like a huge context window. I believe some claim to like have a 1 million context window, and it's important to know the difference is that they weren't trained like on these huge context windows. They basically use tricks to extend the existing context window. So it's not really exactly like, for example, if you're speaking about GPT 3.5 or GPT 4 models, they were trained on that larger context window. And because that training is very expensive, usually if you want to go like beyond 32K, for example, tokens, you don't train that. You use some tricks to extend the context window. But if you go past the trained context window, it doesn't get as precise as a real model trained with larger context window. So it's a bit tricky to understand, but basically with GPT-4 Turbo, you can try to put in a book and you can ask a question about like something very specific. And these models that use tricks will still be able to answer. But if you want to ask like very complex instructions that go beyond the initial training window, they will start to forget something. So it's not like a real usable 1 million token window for the models that claims to have it. So it's nice to keep in mind these limitations.
You might have seen that already if you use some AI in maybe your Outlook or other mail system, and then you say like, please paraphrase what I missed, and then it's not taking like the whole time frame, but just a part of it. It's usually because the limits are reached. Yeah, so that's my dish. And also always be aware that we have statistical bias. So however we train them, and with the training data and context, we might also set bias. So we have some things that might have, like Microsoft Responsible AI, just to take that.
And yeah, it's important to know that when you're asking something to an LLM, it will basically just reflect like the data that it was trained on. So if you try to ask a question about any opinion, it will just reflect the opinion of the data. It's not just like a general answer or anything. It will just reflect the bias of the data that was trained on. So maybe some of you have some like example bias that we can find in some data. If we think of
if you ask it about London Bridge, if you Google search London Bridge, which bridge do you reckon it's going to come up?
Yeah.
Which like 9 times out of 10. So if you generate an image 9 times out of 10, you will get.
And what kind of result do you expect from that?
For the results,
Yeah.
almost always Tower Bridge.
Even though you have like hundreds of bridges in London, so you will have guests that would be like in the percentage as well. Okay, that's great. It also reflects to like also like speech models. So like when I'm in my car, it also understands my language. I have to go a bit deeper, so otherwise it just won't understand.
Yeah, for example, just to keep to stay in a developer context, if you try to ask, for example, what's the best language to use to like solve this particular problem, it will not like try to basically answer like if you get an answer from a human, it will basically answer you. If you ask me, it will be always JavaScript. If you ask Sandra, it will be Java, and it will be the same for LLMs. They will ask the most code they've seen, and it's usually Python to these days. So, yeah, you should be just aware that when you're asking such questions to a model, it comes with limitation. You won't get like a general truth. It just reflects the data that was in its training.
Okay. And how do LLMs work? So we use embeddings. So we put our text, we tokenize it, then we put it in an embedding model. So like all our tokens get a vector representation, put them into tables. And then the closer like the vectors are to each other, the more similar are like the like context-wise the words or tokens. So like if I have like banana and apple, it should be kind of close, or at least more close than banana and cat. Yeah, even though cat is always like a multiple tokens, I don't know, LLMs hate cats. Dogs is always one, usually. But yeah.
Yeah, once you get the vector, you usually take the vector you got as the result of the embedding model, you put it with the text, and you store that into a vector database. And you will see that it will be used as a memory for the large language model, and we'll see that later with prompt engineering that it can be really useful.
Okay, for prompt engineering, we have multiple like techniques we can use. Like one is zero shot, so I just give it a prompt and I expect an answer. Like here, translate the following text in French. So again, hello world, bonjour le monde, and so that's it. But then we also have few shot.
Yeah, basically, few shot is just a nice word to say. We give in context examples. So in the prompt, you say some example about what you expect. For example, if my prompt is like one phrase in any language, and then after that, I put the name of the language in English. And yeah, when we ask, I wouldn't say how to pronounce that last line, but the output gets Swedish because we gave it 3 examples, and it knows, okay, we expect the name of the language after the sentence in there. So yeah. When it doesn't work as zero shot, you just put some examples, and it usually works best. Now, Sandra explained at the beginning that these models are not really doing some reasoning. What they do is just text completion. But we have some prompt engineering techniques to simulate like human-like reasoning, and this is what we call chain of thought. Basically, if you ask this question to an LLM, like when I was 6 years old, my sister was twice my age, and now I'm 30. How old is my sister? So it's pretty basic problem. But if you ask that question, for example, to GPT model, like 90% of the time, it will just try to do some calculation and answer like 24. Just take the 2 numbers, do some addition, subtraction, and you get a wrong answer. But if you adjust one line and say, okay, let's think step by step, instead, it will try to rephrase the problem and try to simulate result. It will basically complete and try to determine which step it needs to get to the answer. And this time, the result will be reversed. Like it will get the right result 90% of the time. So just by adding something very simple in the prompt, like let's think step by step, you get a very different answer. And you know, a lot of newer models that claims to have some reasoning embedded, they just basically built in this part of the prompt inside the model. And so yeah, this is how they get this kind of results. You want to take that one? Or?
Yeah, sure. So for retrieval augmented generation, so that's like the full rec pattern we have in the workshop as well. So we have the user query, and we use the embedding model to like retrieve what vectors are like, or what's the vector representation. Then we can search what's like similar or what is like content-wise a good fit in our vector database. Then we get like the top results, and then our augment prompt will like be generated and then give us back the result. Right? Do you want to add something?
You can see that in the prompt, basically what we get is a fancy word to say that we get the user query in the prompt. You say it goes usually like this: okay, answer to this user question using the following documents, and then you inject the documents that were retrieved for doing a vector search in the database. And that's really how you try. It's really an important concept when using LLM, because if you try usually to ask some general knowledge question, you get the bias of the training data, but also sometimes you get like completely fake answers. You get hallucination of the models. It will try to make you happy by giving you an answer, but the answer will be completely wrong. So a good way to prevent that from happening is using retrieval augmented generation. So that's why it's a hot topic right now, because instead of just trying to get you an answer that it may or may not have from its training data, you basically provide the data that will be used to generate the answer. And the prompt, usually you say, okay, you use the data that we provide to generate the answer. If you don't know, just say that you don't know. So at least if the knowledge isn't found in your vector database, instead of inventing something, the answer will be, okay, I don't know, I don't have enough data for that. So that's completely fine. And that's usually also how you prevent like going out of the rails using that. So you just give it the data, you say, okay, just reformulate this data to answer the question. Otherwise, just say that you don't know. And it prevents like unwanted question. I don't know if you heard about like the story, I think it was Chevrolet. The Chevrolet brand. Did you know that they were trying to put like a ChatGPT chatbot very quick? Did someone heard about that story? Basically, if you were asking their support chatbot what's the best brand for electric cars, it was answering Tesla. For Chevrolet, it was really not the best result. So yeah, because they didn't ground the answer into any data, they just used the model like this. So this is a way to prevent such things from happening.
Okay, so yeah, the next question would be, do I have to be a Python expert? And no, you don't have to be. Like for React, you have frameworks in probably all common languages. So like for Java, we can use LangChain4j, Spring AI, and there's also semantic kernel with a version for Java. The most used currently is LangChain4j because it's like I think the one most long in the race. And then you also have Spring AI, which is supported by the Spring core team, so it's gonna have its presence as well. So for this workshop, we're gonna use LangChain4j, but we also have like versions for Node.js here. So yeah, here you can already see how it works. Yeah, and we're gonna use OpenAI. So we have, I think OpenAI is like the most common, the first also artificial like research company everyone heard of. We use ChatGPT here. There's also like the DALL-E 3 one, which can generate images, or GPT-4, like better text completion, but also like GPT-4 vision, which could also like do the way around from DALL-E 3, like getting an image and then explain what's on the image and also where to find it. I love that tool for like all my alt text for my websites, which is so great. And yeah, and we deployed on Azure since they pay our bills. And also we have Azure OpenAI, which will get also responsive AI on it. So like especially for DALL-E, if I ask for an image creation, it will always add something to my prompt, like automatically. Like if I ask for 3 horse race, it will always put like a brown horse and a white horse, and also different races. Also, the jockeys were like all different races and colors each time differently, because it's also worth mentioning. It's non-deterministic, so we never have the same answers. So make sure to save it if you need it, because and it's also so much fun if you live present and never back on it. So here's the workshop.
And yeah, if you want to complete, and basically, I will put the link after. Let me just show you the end result of this workshop. So it should be in this one. Okay. So basically, what you will be building in there is a ChatGPT-like experience, but instead of just answering from general question, it will use a knowledge base built from PDF documents to answer some question. So here we use an example, a fictive company that's called Contenso Real Estate. It's basically just like an Airbnb, and we gave it some PDF documents to build their knowledge base. So we've went through all the word processing that Sandra explained. We created vector from these PDF documents, and here we're using these PDF documents just to get the answer from your question. And you can see, okay, I just asked how to search and book rentals in there. Let's zoom a bit. So I got some answer. I got some citation from the original PDF documents that were used to generate that answer. We also could generate some follow-up question. So basically, the workshop will be you building this application. The whole backend is the focus, but you will also have the front-end component for that, all deployed on Azure. And yeah, if you want, just instead of these fictive company documents, you can use your own PDF to try it with your own. So the workshop, just I will go back and put the link in there. But the workshop is also open source. You can find the link in there on GitHub. And yeah, it exists in a different version. So the link I will be sharing will be for the Java version, but it also exists in Node.js if you prefer TypeScript, for example. And if you want, so this particular version of the workshop is the one we will be doing at Devox tomorrow. And if you want, you can do the work on your machine. We provide a proxy. It will be up until the end of the week for Azure OpenAI. So you don't even need an Azure Echo to follow the whole workshop until the proxy is up. And yeah, you can do everything, build the application I've just shown. And after the end of this week, I will take down the proxy, but you can still access the workshop, and this one will stay online, but you will have to deploy your own Azure resources, or you can use, in the Java version of the workshop, you can use Oyama. If you have a machine powerful enough, you can use local models. So it will work the same, but just not on the cloud, but everything will run locally on your machine.
So like for me as a Java developer and also architect, I love the small language models because we're already used to like the domain-driven design concept. So I have like very small domains, so I don't even need like large language models because my particular service should just have like domain knowledge. I want to train it with that one, and I would love to be like, first of all, in full control, and then it would be like so cool if it's like that small. I can just put it like in a container as well in a sidecar, and have like I can deploy it everywhere. So that's possible with those small language models. So.
And that's it. If you have any issue with the workshop, you can, it's a GitHub repo, so you can always open issue or ask question in there. And we'll be basically here to answer that.
Questions in the following break. Do we already have time for questions, or should that be afterwards?
Yes, we have like five minutes for questions.
Do we got questions in the chat?
Yes, we have one question in the chat.
Okay, and then I see your hand, so.
Am I going to answer the one in the chat first, or?
The chat.
Do we know where the chat is, or do you want to?
Yeah.
Oh, yeah.
Can we use the vector DB such as Redis to better manage conversion action memory? As user SMS more than once and return the response. So basically, the question is that we can use another vector database like Redis to answer conversation memory. Yes, the one we use in the workshop is called Qdrant. It's an open source database. We have a version of the workshop that use AI search, or you can use basically any vector database. It will work the same. It's just used to store all the vector data along with the original text. And yeah, regarding the chat memory, you can also use just a regular database if you want, like for example, just like in ChatGPT, save the user chats, maybe have different threads. That's I believe also available in Copilot. So yeah, just to save the chat memory, you can use just JSON and any database like PostgreSQL or whatever.
Sure. Okay, you had another question?
Yeah, you mentioned Olama. So particular use case might be not to use OpenAI's, any of their APIs because you have maybe private data, so you don't want to expose that to, public APIs. Using small LLMs or locally, is it possible to maybe work on tabular data? Because a lot of the examples I find online is all on unstructured data. How would you approach maybe tabular data using something like Olama? Because a lot of them are like large data text corpuses, and a lot of the time you see it on using OpenAI, and all of the solutions are quadrant, maybe with OpenAI. But using Olama, I haven't found like a really good solution which works nicely on tabular data as well. And a lot of enterprise and corporate have plenty of tabular data to work with.
So yeah, I think there's two parts in this question. First, as I understand, let me tell me if I'm wrong. You understand also how we can work in private context with LLMs. So I would say Azure OpenAI is part of the solution because you can deploy it like in Azure. You can create your own virtual network. You can create your own not public network with an Azure OpenAI instance deployed. So you can do that and deploy your own internal ChatGPT without any data leaking out to the public. And that's also a good reason for using OpenAI instead of the OpenAI API because it doesn't go to the public cloud. Yeah, another question was how to use like Ollama and local models to process tabular data. So I would say it depends on the model that you're using because with Ollama you can download any sorts of local models. So if I just go to the Ollama website, you can see that it has like a lot of models, and I believe the latest Llama 3 model and Mistral are the best currently that you can use locally, at least on a smaller machine. If you have like a powerful multi-GPU machine, you can use the biggest Mistral model that are almost on par with GPT. But yeah, it will depend on the training of these models. So basically, it's you just try the models that may work or not best. And what you can do if it doesn't work is maybe try fine-tuning the models to suit your needs. So yeah, if it doesn't work out of the box with tabular data, you can just feed it some data, train it outline because you need powerful GPU for training, and then get the fine-tuned models that works better with tabular data and use it locally for your own use case. With Ollama, it's really easy to use any model that's not listed in there. Basically, you just download it and you create an XML file to import it. So it's also possible to do that.
So just curious, maybe it's not only an AI large language model problem, but maybe also like a software problem or how I program this. So if I want to give more context because I know why we have those specific tabular, maybe I should give that as well.
Yeah, another good way also to process that is that sometimes if it doesn't work out of the box with your own data, you can add some pre-processing and post-processing steps before. Instead of feeding, for example, just tabular data, you transform that data into JSON, for example, and then take back that JSON after you get an answer and then convert that back into the tabular data that you needed. That's also an option because these models usually works better with JSON as a format.
Thanks. Any more questions? Okay, well, thank you very much. Thank you both. So we are going to go for a short break now, and we'll be back at 7:30 with Marlene's session. So I suppose do you have a network, or do you have to rush? Or?
We have to rush because I believe we will already be late.
Okay. This is your last chance, everyone, if you wanted to ask any question at all, because Sandra and Johan have to run.
Yay!
When you're querying these large language models, usually, as you said, there is a limit on input tokens and output tokens. So if I have, let's say, a PDF and I want to query the PDF, it's too big, 1,500 pages, you can't really query in a go, you have to chunk it up. How do you really find out when are you hitting the token threshold? I've just tried a bit, and it's like a guessing game. You try it, it says doesn't work, then you chuck it down further. How do you know, like in terms of input tokens, how many tokens are these?
Usually, I don't know if you can do that with the local models, but with Azure OpenAI or OpenAI, you get token usage with every query you make. So if you go over the limit, I think the OpenAI API will just answer an error. You say, okay, too many tokens in the context. I can process this request. And if you are approaching the limit, you will get in the feedback the answer. You get also JSON data to say how many tokens were used in the query and in the answer. So you know where when you're approaching the limit. And another option also is the one not in that workshop, but if you go to the workshop link, we have some reference for in the conclusion. I will just show you that. We have some already built enterprise-ready samples for that. And if you go, I know the Python and JavaScript version implement that. We calculate the token usage before sending the request. You have basically the tokenizer, you run it locally, so we can estimate the number of tokens that will be sent to the model. And if there's too much, we basically reduce the context that much. So you can do that also locally, just not as a guesswork, but you can calculate how many tokens such a specific amount of text we use.
Right, thanks. Is there an example in there? You said that, right?
Yeah, the links you have at the end of the workshop, it's basically sample code. So you have the one for Java, .NET, C#, and Python, and they will all be like a version of what you will be building in this workshop. Basically, ChatGPT using write on PDF documents.
Thank you.
Sure.
Thank you very much, both. Thank you for sparing some time to come and speak to our community. And I will add this link to our resources as well. So, but thank you very much for today.
Thank you.
Thank you. Okay, well, thank you and welcome back. I hope you enjoyed dinner. So we are back with another session with Marlene. She's going to be talking all about deploying apps with Python and Azure. I'm going to let you take away.
Hi, everyone. So the title of my talk is called Playful Productivity, but yes, it's going to be centered around deploying apps with Python and Azure. But before I get started, I thought I would also tell you a little bit more about myself, just so you can get to know me and what I do. I am a senior developer advocate here at Microsoft. I actually just recently joined. I've been at the company for, I want to say, about 2 months now, barely 2 months, actually. And so far, so good. Hopefully this talk goes well. But I focus on Python and artificial intelligence. Those are my areas of interest. And I really love coding. I love coding in Python and anything to do with machine learning or AI. I particularly like that. And if you are on GitHub, I can definitely recommend following me. I just want to give you sort of a preview of my GitHub. Oh no, I don't know where it is. Hang on. Let's see, this is go to GitHub. Marlene. Oh, here we go. That's a preview of my GitHub account. So if you want to follow me, I try my best to post like anything that I'm experimenting with. If I find like a cool new AI tool or something interesting in machine learning or something like that, I will share that openly. So feel free to follow me there. I try to be sort of playful and experimenting with that. Okay, so back to the talk. Great. One other thing I will mention is that I'm quite active on Twitter or X, and I'm Marlene_ZW there. So if you're interested after the talk and would like to chat, feel free to reach out to me there. Okay, so just to jump straight into the talk, I titled this talk Playful Productivity because for the past year or so, I have been intentionally trying to increase my personal productivity. And in that process, I started to ask myself, when have the times been that I have felt most productive? And for me, the word that kept coming up over and over again was the word play. So I do want to share like some quotes that I found recently on the internet. The first one is by a guy called Plato. He was a Greek philosopher some years ago, a super long time ago before I was born. And he is quoted as saying, "Do not keep children to their studies by compulsion, but by play." Another quote is from a guy called Carl Jung, and he is a Swiss psychoanalyst, very interesting guy. If any of you have heard of Jungian psychology, it kind of comes from his writings. And he's quoted as saying, "The creation of something new is not accomplished by the intellect, but by the play instinct." And so this idea of play is so beautiful to me and so interesting. And obviously, this is not a psychology or philosophy meetup. This is a tech meetup. And when I think about the times that writing code for me and my software engineering journey has felt like play, it's always been those times when I have this random idea. So I sometimes like wake up randomly at night and I'll have an idea in my mind and I think to myself, I have to make this idea. I have to code it right now because it's going to change the world and it's going to be the next billion-dollar startup. And so I will have that instinct in me and really want to be able to like put that into code. And if I can actually find the right tools and use the right language to be able to do that without a lot of hassle and pretty quickly, that process actually feels like play to me. So in today's talk, I want to propose to you that Python, I love JavaScript, by the way, I'm not a JavaScript hater, but I think Python and Azure are exactly the tools, the library, the language you need and the tools that you need to be able to achieve this sort of playful and productive coding experience. So to illustrate this point, we are going to look at a real life example from an experience I had recently building and deploying an app, a web app with Python. So a couple of weeks ago, I was watching this guy. His name is Ali Abdal. Does anyone recognize him in this room? Do we have? Okay, we got some productivity people in this room. That's great. So he's fantastic. He has a productivity channel on YouTube, and he studied productivity for years. And I remember watching a video that he did. And in this video, he was saying that in order to actually achieve a goal and be productive, you basically only need three things. The first thing you need is the actual goal that you want to achieve. The second thing is a plan to achieve that goal. And the third thing is a system that will help you achieve it or keep you accountable to achieving it. And so we can think of this, an example would be, say, for example, I wanted to run a marathon and I wanted to achieve that as my goal. I want to be super specific about that. My plan would be, okay, I need to start running 3 times a week. That would be the plan. And then a system to implement to do that would be, I want to set a calendar reminder or I want to set an alarm every Monday, Wednesday, Friday so that I wake up and I run. And so that's kind of his cycle. So when I was listening to this, I decided that I should make an app. And I'm going to make a productivity app that's going to revolutionize the productivity world. And for this app, I decided that I was going to use an LLM to receive a goal from a user. And then the LLM was going to create a plan, and it was also going to implement a system to achieve that goal. So in this talk, we're actually going to look at some code that allows us to be able to do that. But before we take a look at the code, I just quickly wanted to make sure we're all on the same page about how the web works and how we will actually be building a website. So we just are on the same page with the terminology that I'll be using. So when we actually think about implementing a website and building out any web pages, we have to think about two things in particular. The first thing we think about is the client side. So the client side of a website is the part that's user-facing. So whether that's Microsoft Edge or Google Chrome, or maybe the apps on your phone. And then you have the server side, which is the computers that are like real computers somewhere. Sometimes people like to call this the cloud, but in reality, these are just like really big computers that are sitting in a data center somewhere. And so what happens is that when you go to a web page, so say you go to like the homepage of Bing, when you actually load that web page in your browser, what's happening is that you're sending an HTTP request to the server. And you're asking that server to get you that specific page. And that server will then return a response. And that response will be content. And it's usually in the form of HTML and CSS, which is a web page. So that's what we're going to be doing with our app. To be able to implement this app, we're going to be using Python, and we'll be using something called Fast API, which is a fantastic lightweight Python framework, and it helps us to be able to handle the server requests and responses that we talked about earlier. It's also, Fast API is also great because it gives us a temporary server that we can use for testing and debugging our code. And then we're also going to be using HTML and CSS to create like a very pretty user interface, hopefully, and a templating language called Ginger that is built into Fast API to also help us render our web page. And then finally, we will be using Azure. Azure is going to help us as the server that we're going to use today. And it's also going to be the way that we're going to connect to our large language model through Azure AI services. And for this example, I'm using ChatGPT. I'm using GPT Turbo, 3.5 Turbo, and a specific version about that. And maybe I will go into detail about that version a bit later. But before we also look into the code, I do want to mention that all of the code that I'm going to share today is available on GitHub. And I will share the link to that just so that you can see it. My lovely coworker, Liam, and I have been trying to create a repository. So if any of you would like to actually clone the code and experiment it for yourselves, you can go to this link in the top there. And that should actually get you all the code that I'm going to share today. There's some of it that I'm still experimenting with. But yeah, so the end result will be a goal planner that we are going to be using with ChatGPT. We're going to give it a goal. For example, playing tennis is our goal. And then it's going to generate for us this list, which is a plan to find a tennis court, get a tennis racket, etc., etc. And then I also have some code to actually implement a system as well after that. So that is the goal. So I do want us to take a look at the code. Whoops. Quick. Great. So here in my terminal, before I actually do that, I do want to mention something really interesting about Python if there are people who are interested in it. But with Python, I think one of the cool things about it is it feels like a playful language to me as well, just in general. And if you didn't know, you can actually type in actually you need to open the Python REPL. So if you're ever on your laptop and you want to try something cool and you want to know more about like what the design philosophy of Python is, you can actually type import this. And we get this really fun and dare I say playful poem by a guy called Tim Peters. And it's a very fun poem that actually tells you about what the design philosophy about Python is. Like it has things in there like readability counts, practicality beats purity, things like simple is better than complex. We want more sparse code as well, better than dense code. So all of these things are design principles within the Python programming language, and you can actually find this poem as well on the Python website, python.org. Okay, so looking at the code, what we have here on the screen, we're first importing a bunch of dependencies from Fast API, which I talked about. And Fast API is the interface we're going to be using to be able to handle our HTTP requests. And then we're also importing some dependencies from Azure Identity. And this is going to be able to enable us to have our app run more securely. And I'll talk about that in just a second. We're also importing Azure OpenAI, which is the Azure flavored version of OpenAI. It works just like the normal OpenAI API, if any of you have used that, but it has a lot of advantages for Azure users. One of those advantages, for example, is security, and also scaling, things like that. We're also going to be loading in some environment variables that we actually have in a file here called .env. I'm not going to share that publicly because that has some secrets. But yeah, here, the first thing that we're doing on top of, at the first bit of this code is that we are authenticating or allowing for multiple different methods of authenticating your Azure OpenAI key. And this code allows you, first of all, it allows you that if you actually do have an OpenAI API key, you can still use that. If you have an Azure OpenAI key, you can still use that. But we recommend, for security best practices, for you to not use keys. This is something that I have recently learned about, that actually using API keys is really not secure for your code. And if you end up, like, by mistake, checking your API keys into the cloud, into like GitHub somewhere or something like that, then what happens is that really makes your app insecure and people can start using your API keys and can hack into all sorts of things. And so what we want to do is to avoid using API keys. And this code here allows us to do that by using something called managed identity. And this part of the code here actually runs that. It gets managed identity from AZD, of which we can sign in. So we're using also something called the AZD CLI, and it allows us to be able to log in. So I'll do AZD auth login. And this should take me to a sign-in account there. And it's going to grab all of my credentials from my Azure portal account, and it's going to store them locally for me so that when I actually call here, when I call default credential, it actually provides those credentials to the token provider here. And I don't actually need to use keys for that because Azure, they were actually brought in by Azure CLI when I logged in. And so that's something that's really cool. I would say that keeps your app more secure. The second part of the code is that we are going to actually initiate a Fast API app. And this is what this line here is doing. We're also grabbing some static files. And in our static file folder, we have an index.html file. And if you saw the picture before, this is literally the wording that we had in our productivity app that we built. At the bottom here, we can actually see that we're using Jinja. So this is the templating part. So we will call using Fast API and we'll provide a plan to this template, and it will render it to the screen when this form is submitted. So this is the HTML that we have here. And just want to check my time. And we're also using CSS as part of those static files as well. So that's all getting mounted in this line here, and we're calling the Ginger template for that. Now, this line of code here allows us to grab the index.html file. So like I mentioned before, when you run, so for example, If you are using Fast API, it can generate for you a temporary server. And so if we run python main.py, it should hopefully work and give us a local host server that we can click on. And it will take us to our app here. And this is helpful in terms of, again, like I said, debugging our code. It's going to allow us a format to be able to walk through the code and see what's happening. So here, if we put, I want to start baking, we can run that. And why am I getting a 404 error there? But it shows us here that 200 means that that rendered okay, and it will give us the results of that call. So what's happening actually is that when we are getting these results here, it's actually having an HTTP post request, which is this request here. And what I've done to be able to get that result is I've taken what the user has given me in this form in HTML. The user has entered a goal here. And this form from Fast API has passed that information to my main.py file here. And that goal that we received from the user is then being passed. It's been taken in here as the form input that we gave to the on the page. The user gave us that input. And we're passing it in here to this message that we are sending to ChatGPT, to GPT 3.5. And so the message I said is, I want to achieve the following goal. Can you create a simple app to achieve this? Return the results in HTML format, but do not include the HTML body and tags. And so again, just by giving the LLM an instruction like this, you're able to kind of interact with the LLM and have results returned to you. I was talking a bit earlier about how you can also, if you want structured output, there's actually a way that you can tell the LLM to generate for you JSON, or you can tell the LLM to generate a certain type, a Python dictionary or something like that. And if you use something called Pydantic, you're able to work with the LLM to actually make sure that the output is structured, and you're also able to do try and fail and accept, so that the code can fail gracefully if it's not working. So all of this code here is basically what runs the app that I showed you. I also have some other code that I'm currently working on, and that shows the more structured test. So this is a bit more of a this is giving the LLM some bigger context here, because I wanted to create a system, and I want to get from this some structured output. And so, like I said earlier, here I'm explicitly telling the LLM to respond using JSON. I'm also telling it I want you to use the task and do keys, and not to deviate from the format. So one thing I found is that sometimes you have to explicitly tell the LLM, don't deviate from this, or things that you wouldn't necessarily think of. You actually have to I think that's one of the things about prompt engineering, is just being more explicit will help your code actually run the way that you want it to. And this actually worked for me. I haven't integrated it into the GitHub yet, but this is the result that I'm getting at the bottom there. And basically here, it's saying it adds some tasks to calendar, and it'll add on June the 3rd. It says start running for 30 minutes on Mondays. It also has something new on June the 5th, and so on and so on. And so this code allows us to be able to generate some structured output. This output is then going to be fed into Gmail or Outlook, actually, for Microsoft, and then you can create a function that will accept that input and place it on your calendar. So that is pretty much what I have for the talk. I think my time is up. Like I said before, all of the code for this talk is available on GitHub if you want to use it. Going for a print interview. All of the code is available there on my GitHub. I'm planning to update this code and make it clean and also add the parts about structured output as well. That uses Pydantic and LangChain actually to be able to do that. And the specific version that I used was GPT Turbo, the 0.125 version, which I was talking to someone about, about earlier. And that helps with generating structured outputs. So yeah, I think that's all for my talk. If you would like to, you can feel free to follow me on Twitter or follow me on GitHub. I'm Marlene_ZW there, and I'm Marlene_ZW on Twitter. So thank you. Questions? Yes.
I was looking through the libraries you imported into your main code.
Yes.
I noticed that Streamlit was missing. With Streamlit, you could get rid of CSS basically and the HTML tags and so on.
Exactly. You're right that I thought I've used Streamlit before. I think it's a fantastic library. I think the thing with Streamlit for me is just making the code, like I feel like with Streamlit, it kind of boxes you into a certain UI. And so I wanted it to be a very pretty kind of playful UI that I created. And with Streamlit, I feel like there's like a certain type of app that it creates that I feel like the UI looks a certain way. So that's the only reason why I used HTML and CSS. But it's I could use that to shorten the code to not have that. Yes.
So the idea of the app is basically you give the user a form where they input the goal they want, then you generate with your code a complete prompt that completes the specifications, specifying what you want to get and how you want it. Then you send to the LLM and then display the answer. Is that correct?
Yes, that's right. So the user, so this goal, no, I'm actually in the wrong file now. This is my extra code that I am playing around with for the system. But in this code here, this goal is the input from the user. And we are using just the form in the HTML to receive that goal. And then we're using Jinja. The Jinja templating method is what will display that goal on the screen to our user. So here, using this plan is what is going to be rendered on the Jinja template. So yeah, that's right.
Thank you.
Any other questions? Yes.
The OpenAI API, is there a dev playground version for it, or you have to buy a subscription to even mess around?
You do have to have a subscription. There is a free tier, I guess, or a free. I think the subscription is free for like a certain amount of days, like the first time you sign up for it. I'm not sure how many days, but then when you're using it, I think you can. Honestly, with OpenAI, with Azure OpenAI specifically, I don't think there's a free tier where you can just use it for free. I think it's charged per like a certain amount of tokens or something. So yes and no.
You have a slower version, something that responds slower but is cheaper. Sorry, you're not an expert on, you may not be an expert on the pricing of it.
I'm not an expert on the pricing, but I would say there's Azure works with open source models. So it doesn't just work with OpenAI. It also has a bunch of open source models that I would say if you're testing stuff out and just want to play around with things and use a free version or a free model or something like that, there are free models that you can deploy that are open source ones. So that's an option. But I will say with the free ones, I have tried them myself, like the open source versions of stuff. And sometimes it's not as predictable. And sometimes the answers that you get are completely off sometimes.
You get what you pay for.
You get for what you pay for, yes. I will say that here. I love open source though. So Any other questions? Yes.
Can you please explain about this extra parameter so I can see the temperature? What is it for?
Okay, yeah. So temperature here is, I've heard it like being described in different ways. I've heard it like some people saying that it's the level of like creativity the model has. So the higher the temperature, the more creative the model's responses are going to be. If you want the model to respond like factually, usually like RAG applications and things will use 0 because they're expecting the model to respond factually. If you want a more creative response or something that's not as predictable, then I think you want to use like higher versions of the temperature. But I've also heard it being described differently. So, but that's how I see it, or that's how I've approached it. Kristen. Yes.
When we asked the model to generate HTML, would you have any like security concerns regarding XSS and like script injection and stuff, or imagine the fast API template sort of handles that sort of thing, or?
I haven't I feel like there are probably gonna be some concerns. There are things we should be concerned about, actually. I think so, but I don't know how we would. I think that using Azure just in general comes with a bunch of other security measures that I think make it a bit more secure to use things like this, to use the model through this way. But I would say, yes, there potentially are some security concerns. I'm not sure if Fast API would handle all of them. I've heard of prompt injection. But yeah, I wouldn't know, honestly.
Actually, in your code, if you go to the HTML Jinja template, there is a plan with a filter of safe. I believe that will strip out all the XSS or any potential XSS codes. So if you could show me that part.
Let's go back to it.
So if you go down, anywhere, wherever you're putting this HTML, for example, line number 26. So the filter, I'm not a Python person, so please correct me if I'm wrong. So I believe that plan is the input and safe is the filter. And this safe is kind of a function that actually runs through the content of plan and removes all these user injected and unsafe stuff.
That's interesting. I'm not sure about that, actually. I've been using Jinja for a while, and I've never actually thought about that.
This is almost similar.
That's probably the case.
Almost similar to what we use in JavaScript as well. At times we use in Angular. I've seen something like filter directives, etc.
Yeah.
Again, I'm not an Angular person either.
Yeah, that might be it. I will actually look into this.
If you could take your mouse cursor and put it on top of safe, probably it can say something.
Let's see if it'll.
It doesn't. Okay. Yeah.
Okay, it's not showing us anything. Thanks. We could ask ChatGPT. We can ask
please.
the chat. Let's do that.
Explain that line number 26.
And by the way, I was supposed to talk about deploying this app, and I didn't. To deploy this app, all you need to do is run azd up in your command line, and that's it. And it will deploy the app for you. So that was the main part of the talk, and I forgot to say it. Anyway, that's fine. But we can ask. Let's see. Let's say, what's the question we should ask? Maybe we should say, in a Jinja template, what does this code do? See what it says. It says
Filter.
Yeah, on a variable plan, the safe filter in Jinja tells the template engine the value of the plan is safe to render directly, and it should not escape any HTML characters in it. Normally, Jinja escapes HTML variables for security reasons. Wow! Can we do this, man?
To be honest, whatever this did is actually the opposite of what I said.
Oh, okay.
So safe safe will not escape it. So yeah.
No, it says that Jinja escapes
it. In normal, it does it safely, but in this case, it doesn't do it safely. So you are telling it not to be safe.
Basically, you are saying that it is already safe.
So we're saying it's safe.
It is safe.
Jinja. That's probably true. I don't know. Let's all Google this after. Let's all check this out after. That's helpful to know. Not know that. Any other questions? I just want to emphasize, I'm just going to type it on the screen for visibility, that to deploy this app, you just run AZD app like that. And then it's starting to deploy the app for you. It runs some Docker commands. And at the end of this, it's going to take a while to actually set up and things like that. But once the Docker commands are done, you'll have like a link that you can go to, and you can share that link with others and actually share your code with them.
And does it require Docker installed?
It does require Docker installed, yes. So containers are actually really great. If you use GitHub, which this code is on, feel free to go to code spaces, because that allows you to like use this code without having to set this up on your own machine. I just chose to use my own machine. You don't have to. In code spaces, you can just run your code and it'll work. Do you have any other questions?
Okay, well,
Great. Thanks, everyone.
Hello, everyone. I can't hear you guys. Hello, everyone. Sorry. All right. So I am Chandan Gupta Bhagat, and I am a software engineer at ALive. So it's been 10 years in the industry with the Microsoft tech stack mostly. But beside that, I'm not kind of like stuck into the Microsoft ecosystem only. I do a few of the things in the JavaScript and get on hands with whatever I can. Sometimes new things comes up, right? So gets your hand dirty with it, right? So, but my main focus is in Microsoft technological stack. So that includes .NET, Azure, DevOps as well. And yeah, I'm at ALive, and there are a few of my colleagues from ALive as well. So ALive, please raise your hand. Yeah. So at ALive, what we do is we are a sports broadcasting company. So what we do is during the live match, during the FIFA live match, during the Premier League live match, right? You see the captions coming in. That's what we do. So not only that, we deal with the data from the different providers, right? And we use some kind of like similar technique to get the data from our providers. And as our friend mentioned earlier, Marlene, how web works, right? So the web is all about like request and response, isn't it? You send the request, get the response, right? So in the browser, whenever you put like google.com or bing.com or facebook.com, right? It's not the facebook.com that's going to the server. There are many things that are appended together and then sent to the server. And as a result from the server, you kind of get like the data in the plain string format, right? And with that string data, you get the additional some sort of like header informations, right? Header informations. And those header actually defines, right, what to do with the data, isn't it? So when you get the data, I could show you some of the samples, right? So when you get the header informations from the server, right, as in like text/HTML, then the browser would understand that the data is in the format of text/HTML. It's like a label that it attached to the parcel, right? So whenever you see a parcel, people wouldn't know what's inside the parcel, right? If you attach the label of something that's fragile, people would handle with care, isn't it? So that's what header information does. Okay, anyway, let's come back in. And web is all about like request and response, right? We send the request, we get the response. And that is not enough for us, you know, because every time if I want to get the data, I have to send the request. There are many things I need to do first, right? So that's where the event-driven architecture comes in. So event-driven architecture is something that is triggering the event, and our application are responding to that event. So most of you may be confused at the moment, right? But let us think this fire alarm system, right? It's a one real example of event-driven system, right? Nobody would care if the alarm is off, but as soon as the alarm is on, what would we do? Would we sit down here? No, we'd run. We would go outside, go with the fire brigade downstairs, right? So that's how event-driven system works. So the event, some event happening, and we are responding to that event, right? So there are many ways to do that. There are a bunch of like Microsoft services in Azure that we can use for this event-driven system. So one of them is using the service bus and Azure functions. There are many other things that we can do it, right? And let's see. So why event-driven? So it's because we need the asynchronous communication first, right? And it's kind of like loose coupling. Loose coupling as in more. How would you define the loose coupling? How would you define loose coupling?
As microservices containers.
Like changes in one of the system, one part of the system should not affect the other part of the system, right? So that's how loose coupling is about. So let's say if I write the code that even a single change in some sort of API, let's say if I'm relying on the Open API, right? Open API or Open AI, if there is some single change in their model, I need to change my code, right? So, but the thing is, if you have to change the entire code base for that single change, that's a tight coupling, right? And if there is like minor change that you need to do, just a small patch you need to do in order to reflect that change, that's how loose coupling works, right? And on here, event-driven system works in that way also, right? it's loosely coupled. So that means change in one part of the system would not affect the other part of the system, right? Not entirely, but there could be some of minor, kind of like issues, but that's not a big deal, right? And scalability. In terms of like scalability, we can scale it up, scale it down as per our need, right? For uh, when I talk about this scalability, it kind of reminds me during our live match. So during weekends, our system in A Live are kind of like scalable to the highest threshold because people are enjoying the live match. And our system needs to be kind of like stable in that case, right? Using the high throughputs, right? And also like real-time responsiveness. So we are also getting real-time responsiveness. That means let's say some event is happening, a goal has occurred, right? And we have to process that goal event real time. We cannot rely on like every 5 seconds I'm polling the system and then getting the data. It's already 5 seconds delayed, right? But if we talk about this event-driven system, the goal event itself is happening and you are getting the data almost at the real time, right? So this is why we require event-driven architecture, and there are most of the other things as well. Like right now, we are having the live stream of the system, of this event. Sorry, right? So if that event, if the moment right now is kind of like 1 minute delayed or 2 minute delayed, it's not the real time, is it? So we need to make it some sort of like real time. So, and that's where service bus is one of the solution, right? And it's not service bus is a messaging service in the Azure platform. I will show you like the demo as well, do some live coding in this case as well. So messaging as a service. So, and the next thing, the messaging pattern are on the basis of like queue and topics. So what queues are, what topics are, I'll explain it in the next slide. I have the diagram. And asynchronous communications and reliable message delivery and so much more, right? Let's talk about this, the demo, right? And the service bus queue versus topic. So queue versus topic is something I could show you like this one. This is the example of queue, right? So here, if you look at this one, we have application, some application. It may be a console application. It may be some simple application. And there is one HTTP request that I'm sending the data to the service bus. And what it is doing is like it's queuing up, right? It's queuing up. That means the first come, first serve basis. Right? On the right-hand side, if you see the Azure functions, these are the Azure functions, right? So in this case, one of the Azure functions is kind of like getting the data from this one queue. It's clearing up the queue, right? So there are 3 functions right now. So that means one after another, the messages are being processed. Okay. So let's say if this system is down at the moment, right? This system is down, the message will be queued up. It will not get lost. So when we talk about this, like in the web applications, client and the server, right? So let's say if the server is down for some reason, when we send the request, we will not get any response, do we? We will not get any response, right? And service bus would make sure that the request that the client sends get in queued. even though our end services are like down at the moment, right? All the requests will be queued up. It will not get lost. And once these systems are on, it will automatically start consuming it one by one at a time. All right. So this is the queuing system, and this is the topic versus subscription. So in the topic, let's say the same application on the topic subscription basis. So the same messages, if I send the same messages, it will go on multiple subscriptions. Right? And our application would subscribe to that topic, subscribe to that subscriptions, right? And consume the data, and it would not affect other messages. So that being said, let's say the message for this one, if the message is consumed for this one, it will also this message won't be affected. But in the previous one, if you see the first message, if it is consumed by this application, right, the second message may or may not be processed by this application, right? Because of the queuing mechanism. Once it is queued, it's cleared, right? This message is being processed, it's over. The next message would go for this one. The third messages would go this one, right? And as many as instance we created, the message would go in that way, right? So, and Azure functions. Okay, so Azure functions are kind of like the event-driven, serverless, right? Multi-programming language support, scalable, and many more. That being said, event-driven, again, event-driven. So that means these functions are triggered through some external events. Okay, I would show you some demo, right? And serverless, as in, why do we say this Azure function as a serverless? Even though we have to deploy it again, right? But the thing is, we don't have to do a multiple configurations, a lot of configurations. It's kind of easy to set up. You just write the functions, it's already there. You just write your code in between that function. And that's all, right? So let's see how our demo would work in this way. So for this, okay. So for this, what I would do is I would go to Azure, right? And since this is a production subscription, nothing is there. It's just the name. Okay. So let's go first and create a service bus, right? So here I'll create a service bus. Okay, so a service bus that you see here is kind of like creating a namespace. At first, at the very beginning, we need to create a namespace. So I believe that most of you are familiar with Azure. Most of us are familiar with Azure, right? So on the Azure, we have the resource group that would have a bunch of the resource in that resource group. So in order to do that, I have to create a resource group. Since there is no resource group at the moment, I will create a new one, right? And I would name it as Reactor Meetup, right? And the name of the service bus. The name of the service bus, I would Reactor Meetup 2024. Right? The location is this one, and the pricing tier is one of the most important factors. So if you look at this one, we have 3 pricing tiers. Right? The first one is the basic one, second one is the standard one, and third one is a premium one. So if you choose basic, you only have queue. You won't have the topic or subscriptions. So in order to have the topic and subscriptions, we need to choose the standard one. Okay. And which also has like the pricing. And for the pricing things in the Azure, we have Azure pricing calculator as well. So did you know that? So we have the Azure pricing calculator where we would actually look after the services based on the configuration, how much it would cost to us, we can get the idea. So let's say here, if I'm using the service bus, how much it would cost me? Service bus, add to estimate. So here, where's the Kubernetes? Not the Kubernetes. Okay. I would add to the estimate and I would see, like, if I choose the basic one and choose 1 million request, 1 million operation per month, it would cost me only 5 cents. Right? But if I choose the standard one, I would have to pay like 9.81. And also the location would, and at some point, like location would also change the rate as well. So you can have a look at this one. Right? I mean, this is the pricing tier I would choose is the standard one to show like the topic and the queue as well. Right? So next is our advanced. So on the advanced, we would leave it as it is. There are many other configurations on the networking. I would have the public access and the private access. But at the moment, we need the public access. So I'll choose this one. Tags is the last thing that we'll worry about. Like it's kind of like adding the tags to our system. And finally, reviewing and creating. Okay. So once we clear this, okay. So, yep, it is starting to deploy it, right? So meanwhile, it is being deployed. Shall we go ahead and see what Azure function is? Yeah. So what I would do is on the Visual Studio. Most of you have been aware of the Visual Studio code, right? There is also some of the extensions from the Visual Studio that you can use it, right? And you can create a new project here. So on creating the new project, you have a lot of options right here, out of which you choose the cloud, right? And on the platform as it is, right? And using the C#, right? If you scroll a bit down, you can see something like this, Azure Functions here, the Visual Studio, right? So the next step is to name the project. So I would say Reactor Meetup. So yeah. So based on our .NET version, we can choose the .NET, I think. You can see that, right? Can you see it? Yeah. So what's the .NET 8? Oh, it's not there. Anyway, I would choose like .NET 6 at the moment. And here you can see a lot of triggers. So let me zoom. What's that? Magnify, sorry. Oh. Okay. So if you look at this one, right, we have many triggers, right? The functions are of different types. So based on this, there are durable functions, right? So let's forget about durable right now. It's a long running functions, and we can orchestrate it, right? So those are different things. So we have event grid trigger. So that's one of the service in the Azure event grid, right? It's equivalent to Kafka. Okay. Event hub, right? Again, Kafka. You can have the Kafka trigger as well, right? You can have the HTTP trigger as well. So that means you can make a serverless HTTP request on this one, Azure Functions. You can have the IoT hub trigger. You can have queue trigger, right? This one is the service bus queue trigger. This queue is the storage queue, sorry. And here you have SendGrid, RabbitMQ, service bus queue trigger, service bus topic trigger, right? SignalR, SQL, and there are Cosmos DB as well. I'm not so sure. Here it is, Cosmos DB as well. So at this point, we need to create one of the queue trigger and one of the topic trigger to see like how data is coming through, right? So let's deal with the queue first, right? And here on the queue trigger, so we need a connection string name. See, the next thing I chose the service bus queue trigger. It prompted me for the connection string name, right? And the queue name. Okay, so right now the queue name is my queue, and I need to add the connection string. So for this, let's go back to our Azure to see if the thing is deployed. Yeah, the deployment is complete. Okay, and the next thing we would go is get the connection string. So the connection string you could find is in here on the settings sections. You can find it here, shared access policy. Okay, so here you can create the shared access policies based on need, right? So let's say one of the policy we can create is just for sending the data. That means it won't respond to listening, right? That connection string would not be valid for listening. So if you are creating some sort of like connection string for listening, it would not allow to send the data. So we can actually define as per our need, right? So right now we have this one, root managed shared access key, right? And this is the connection string. Okay, so this is the connection string. I would copy this connection string, and here in the connection string setting name, right now I would use connection. Okay, I would use connection, and the queue name is my queue. Okay, and here, not here, here. After doing this, let's go back. Sorry, let's create this one, right? Meanwhile, it is creating the project. See, it created one of the template. The function name is function1, the service bus function. So right here, right? So here, connection strings, right? And here, connection, and finally paste the key. That's all we need. Okay. And since our function right now, what it does is like it logs the information, whatever comes through that queue item, it logs it. But the thing is, we need a my queue, a queue called my queue, right? So let's go back to our Azure. Here on the overview, you can see queue and topic. So if you're choosing the basic one, this will be disabled. All right. So on the queue section, right, let's create a new queue called my queue. And we can define the queue size also, right? So we can have the max of 5 ZB, and we can have the delivery count up to 10. We can have the message time to live for 14 days. So after 14 days, that will be expired if not used. Okay, so we can enable the duplicate detection. That means if somebody is like constantly sending the same data, it would like detect it as a duplicate and only add just one request to that, right? And yeah, so there are many configurations that we can do it. But let's create a simple MyQ to say, right? And I have created one of the application here on the GitHub slash. So on this repository, this is one of the organization, right? So here, if you go to the repository section, you can have tons of like the repository demo repositories that I have been using for the sessions. So one of the latest that one I added this morning was service bus demo. Since this was added a long time ago, like 2 years ago, I added one of the service bus token creation, right? So you can clone this. Let's clone this repository and Reactor. Yeah. I would go to the terminal and then clone it. So here in the service bus repository, there are 3 projects actually. So one is the Azure storage. So one is the Azure storage. One is the console app service bus. So this application, what it does is, it's a simple console application that sends the data to the service bus. Okay, we can send it through the HTTP request as well, but you can test it easily from this one. So in this service bus, I have a sender and a subscriber. This one, where I no, not this one, placed in this one. So at the moment, what I will do is I will just replace the connection string that we have this one. And so connection string, I will paste it right here. And instead of topic name, I will name this as a queue name. Okay, queue name. So I'm renaming this as a queue name. So in this queue name, what would be the queue name? My queue. And here I'm simulating to send like 100 of messages. Okay, so let's try to send this. Right now, this Azure function is not in the running condition, right? And the service bus that I would run right now, it would send like 100 messages, one after another. Oh, that's a wrong .NET framework. So 5.0 sends it as a 6.0. So see, we are sending the message. So 100 messages are being sent. Okay, And let's look at the service bus. I know it's late, please bear with me. So right now, if you look at this service bus queue, we can actually use the service bus explorer to see those messages right here without losing the data. So the 100 messages that we sent is still here, even though my Azure function is not running at the moment, right? So slow. Mode.
Yeah, you're using topic file.
Ah, right. I did a mistake. Sorry. Yes. So even though I changed the right out of excitement, IQ client, right? I would name this as a Q client, right? And leave everything as it is now. Just the variable name is as it is. Okay, anyway, let's send it again. See, now 100 messages are sent to the queue. So let's refresh it. See, 100 messages in the queue, right? So we can pick from the start to see those messages here. Those messages are here at the moment, right? And the moment it's not consumed, that queue is not consumed, right? So our server is down right now. So let's say if I run this server, it will start fetching the messages from that queue and start consuming it. So if you look at this code, this function, right, it just logs the item as a C# service bus queue trigger function process messages and my queue item, right? And here we go. See, we got all the messages from our service bus. So now the queue, all the items in the queue are processed, right? And you can see the messages that we sent, message 33, message 70, although it's not in the same order that is being processed, but it actually is getting that in the on the basis of queue, and so on, like with the topic, right? And if you go with the topic, not here. Yep. So on the topic, so we can create a topic, right? A topic called reactor, right? And I'm creating a topic called reactor. And in this topic, what we can do is have a multiple subscriptions, right? So having a multiple subscription means our client application would subscribe to that subscription. So let's say if I have 3 of the applications that would consume the same amount of data, I would create 3 subscription, like sub 1, sub 2, sub 3, or whatever the name is as your name, right? So on the subscription, you would add, like, let's say sub 1, and then create it. And again, another subscription called sub 2, and then again create it, right? So now we have 2 subscriptions. Oh, my bad. So 2 subscriptions, sub 1 and sub 2, right? And let's go ahead and send the same message in the service bus topic. So it's the same code, just we remove this topic client with the queue client. Sorry, queue client with the topic client, right? And now when I send this message again, not this one, the queue name or topic name, what was the topic name? Reactor, right? So I would name this topic as a reactor and then run it. So now what happens is, now after sending 9900 messages, here both of the subscriptions would have the same amount of messages, that is 100 and 100, both subscription. See right here, so both of the subscription would have 100 messages, right? So now if we are trying to subscribe the subscription 1, right, it would consume every items from this one, right? And the sub 2, if untouched, it will leave as it is. So another client could subscribe to that sub 2, right? It's the same process. So let's see the quickest way of adding the Azure function. Almost done. New Azure function, and on the Azure function, I would add this as a topic. So here we would have a service bus topic trigger, right? The connection string same as connection, and the topic was reactor, and the subscription name I'm giving as a sub 1. So that means now if I run this function, now only the sub 1 would be consumed and sub 2 would remain as it is. If there is another application who would subscribe sub 2, now the message will be processed by sub 2. So that's how we trigger. Oops. See? Now, finally, if we look, if we compare this, refresh the data, see? Sub 1 has been consumed and sub 2 remains as it is, right? In this way, we can have the multiple subscriptions in our topic. So we can have multiple topics as well, but at least in this case, we can branch it off. Our data can be branched off among multiple clients. Yep, that's all. Any questions? Quick questions. Any questions? Yes, sir.
Normally, is on Docker,
I mean, there are many other ways to do that. It's just one of the methods that I have demoed you, right? There are much more efficient way to do it. Any others? Yes, sir.
If I substitute the service, I'm just looking at it from a cost perspective. If I substitute the service bus with event grid, I get same results. The outcomes will be the same in terms of.
Sorry, I didn't get you.
I'm just looking at it from the perspective of cost. Service buses tend to be expensive. If I substitute service bus for an event grid, they share very similar components. Very similar. Will the results be the same?
Event grid is actually the event-based system, right? The service bus is actually the message-based system. So there is kind of like a difference, I would say. And the size limit, the size of the message also matters here. So if we are choosing like the service bus right now, in the standard tier, the maximum size it would support is 256 kilobytes. And if you are using the premium one, it would support like 1 megabyte. So there is alternative which you can use it, like Kafka is one of the open source. You can use Kafka as an alternative to service bus if you're worried about cost. So you can also have like the Kafka installed as a Docker on your machine and using the same concept of having this message-based system there as well.
Okay, sorry, we just have to quickly wrap up. Thank you very much, Chandan. Thank you.